This is a video for the second day of pre-calculus graphing and eliminating the parameter of parametric equations. So on page 5, to make our graph, we have to get some points to put on our grid. So make sure your calculator is in parametric mode. We hit the mode button in parametric. So when you go to y equals, all right, yours should be clear. If something's in there, delete it. So in x1, I'm going to put 3t. So this input button, this variable, changes with the mode of your calculator. So it's giving me a t because we're in parametric mode. And in y1, I'm going to type t squared plus 1. And then before I keep going in my calculator, in my table here, I'm going to write down the t values this problem wants us to use. I'm going to make the calculator give me the same t values. So if I go to second window, see how my independent says ask? If yours does not, arrow down and hit enter there. Now I can do second graph and type 0, 1, 2, 3, 4, and 5. And I get the x values and the y values for my graph. Oh, it's easier to go this way. All right, so you write them on your paper as well. And so what I notice, if I have to go to 26, I think I'm going to count by a scale of 2. I'm going to make this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's still not going to be on this grid, but that's okay. We'll estimate. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26. So when I put my points, the t is not going to show on an xy coordinate grid. So I have to somehow explain how that's going to play to make our graph. So I do 0, 1, 3, 2, 6, 5, 9, 10, 12, 17, and then 15, 26. So when I connect the points, I can either label each point with a t equals, and the value I got that x and y from, or I can put arrows like this on my graph to show the movement from time 0 to 1 to 2 to 3 and so on, all the way up to t5. All right, what type of function? And let's eliminate the parameter. So eliminating the parameter means eliminate the t variable. So I need just x and y. Remaining. Leave your answered in factored form, and then I'll be able to figure out what kind of function we have: linear, quadratic, cubic, sine, cosine. We'll figure it out. Because this is t squared, I'm going to isolate the t in my x equation and then use substitution to replace the t. So if t equals x over 3, I replace this t with x over 3. Leave your answered in factored form. This is factored form. I've got a term squared. So when I have an x squared graph, this is quadratic. All right, let's do that again on page 6. See if you can get your calculator to pause the video. See if you can get your calculator to give you these values for the table. So now I'm going to graph them. Oh, again with the 15. All right, well, so this goes up to 10, so I'm just going to make that go off the grid. So I've got negative 2, 3, negative 1, 0, 0, negative 1. All right, 15 will be up there. Oh, I missed. All right, you got the idea. But I need these directional arrows to show the pathway of the graph or particle, whatever we're graphing, from negative 3t to positive 3 for input of t. Because for these parametric equations, now the t is your input, and x and y are both the output of the parametric equation. Just based on the way this graph looks, the type is going to be quadratic. Looks like a parabola. Let me copy the equations down so I can eliminate the parameter. Again, leave our answered and factored form. So I'm going to subtract the 1 to the x side and replace these t's, both of them, with x minus 1. And this is factored form. I have an x squared, so that's quadratic. All right, so your practice is page 7 and 8. That is your homework. I will do number 1. Maybe let's do number 1 together. I don't see any exponents, so I'm going to rewrite my equations vertically. And I reorganized my x equation so the t's were lined up. Because now to eliminate the t, if I take this x equation and multiply everything by 2, recopy my y equation. If I add these equations together, my t's will eliminate to 0. So I get 2x plus y equals 5. When we have an equation where there's no powers, it's going to be a line. And I like linear equations where it's y equals. So I'm going to subtract the 2x to the right. So we got y equals negative 2x plus 5, and this is linear. All right, so for number 2, you can set this up the same way. I got to resituate my y equation. Multiply this one by negative 3, because I want to be able to add to positive 3. To eliminate the t. All right, so if I add these together, x plus negative 3y equals 4. That looks like 12. All right, I want to isolate the y because that's another linear equation. I'm going to subtract x and divide every term by -3. So I've got y equals, this is -1 divided by -3, so that's positive 1/3 x minus 4/3. If you would rather do substitution where you isolate the x variable in the isolate the t variable in the x equation and input that into the y equation, you can absolutely do that. Okay, so your job is to finish page 7 and page 8.